I'm also going to open the floor to the audience to ask questions, but I'm going to start with a question to Hugo first. As a startup, how do you see yourself competing with already established manufacturers like Toyota or Hyundai?
Well, actually, we believe that we can only do this from outside the industry rather than from within. When you're developing relatively mature systems, you need scale, you need a lot of money, a lot of people, a lot of time. System-level change can be done quickly and cheaply by small teams of people, and actually agility is much more important. And although we communicate with car companies, have a very good relationship, actually if we were to work with them and to be useful to them, our baggage would become their baggage, and we wouldn't be able to do what we're doing today.
Okay. Do we have any questions from the audience? We have one question there.
Again, Waddah Al-Hanahi from FANA, Federal Authority for Nuclear Regulation. I have just an observation on CO2 storage in oil reservoirs. That is an eye-opener for carbonate geology, which is in the Gulf region. We noticed that CO2, when injected into the formation, the geologic formation, being carbonate, limestone and similar, it dissolves in water to form carbonic acid, which itches the formation. And therefore, there is the danger of collapse of the formation and subsidence of the ground. Have you have this experience from your work?
Well, that's not been the experience that I've seen. I'm not a geologist, but I work a lot with them. So when we're injecting the CO2 into the earth, we're injecting it deep. So I'm not quite sure how deep you're injecting it here.
10,000 feet.
How much?
10,000 feet.
Okay, so you're injecting it quite deep. What we see happen is it displaces the groundwater, and it does dissolve in some of the water at that depth, but we haven't seen, obviously it forms carbonic acid, but we haven't seen any negative effects from it because these are deep formations, whether they're depleted oil and gas wells or they're saline formations. And eventually, over time, you actually see reaction with some of the rocks in certain of these formations, and it's solidifying. So at least my understanding, what we've seen is that the underground injections that we've taken place have worked well. We do need more experience to understand it more, but there's been a lot of injection in oil fields for enhanced oil recovery, especially in North America. And I'm not aware of issues like that.
That's the question. In North America, maybe you didn't have carbonates. Here we have carbonates, limestone, and they are very, they dissolve in any acid, even if it is a weak acid like carbonic acid.
So, I mean, that's a good point. Reservoirs are heterogeneous, so not every reservoir may be amenable to carbon storage, but the ones that have been tried, and it's not just in the U.S. Norway has done injections in the North Sea. There've been injections in Australia, and actually, they're doing just next door in Abu Dhabi. They're capturing carbon from a steel plant and injecting. I don't know if that's what you're talking about. They're injecting it for enhanced oil recovery there. Is that where the problems are occurring, or?
Yes, exactly.
Okay.
Yeah, and we did lab experiments and repeated the experiments to really reconfirm what we were noticing.
Yeah, so I'm not, that's a fairly new project, so I haven't read much about that, but it's something I'll have to look into more. Thank you.
Actually, Donald, I have a question for you. What kind of policy do you see helpful in accelerating the adoption of clean steel production? Is it penalties? Is it subsidies?
Oh, good question. I'm not a fan of subsidies. I really think that if the new technology is going to be embraced, that it should be cost competitive on its own merits. That being said, there are ways to get into the network because there are very tight relationships between steel companies and customers. And if a customer sees a new producer, that customer may have strong disincentives to even sample the product of the new producer for fear of being cut off by the major supplier. Mm-hmm. So in the United States, the number one purchaser of steel is the federal government, and that steel goes into roads and bridges. And so they could have a policy switch where they say that moving forward, the people that are building these roads and bridges are obliged to buy steel that has a low carbon footprint, and that could be a carbon footprint that is progressively getting lighter and lighter. And that would not disturb the entire system, so the old producers could still participate, but it would force them to move, because otherwise they'd just say things are good the way they are. So I think that by putting that, and then, you know, the other major procurement is with the military. And if between rebuilding infrastructure, repairing infrastructure, and military spending, if all of that were mandated to be low carbon product, and then you could extend it to other pieces as well, and that would stimulate, even going to vehicles, and say we're going to insist that the vehicles progressively are lower and lower carbon, and you'll see a big change. And then the manufacturers are sitting there going, we can't produce one set of vehicles for this market, another set of vehicles for this market. It will flip the entire paradigm. That's a thought.
Interesting, thank you. Howard, you mentioned that the direct air capture is expensive, it's costly. Do you think it can be reduced, the cost can be reduced, and if so, how?
Well, I mean, you can always reduce the cost, and when you talk to these companies, the biggest thing they're going to do, especially a company like Climeworks, where you see they have that unit where they're just going to have to replicate. They think by making many units, they'll bring down the manufacturing cost. The problem is on the energy side, and you can do a thermodynamic analysis, which has been done, and you look at these, and it's always going to take a significant amount of energy. So I think the most important thing you can do to make these more cost effective is have a very inexpensive supply of carbon-free energy to drive these processes. And I think that's the key thing. If we had that supply today, we wouldn't be in the trouble we're in with climate change. It's going to be a challenge. So as I say, I don't see it happening in the next couple decades. Beyond that, it's always hard to predict.
Do we have any more questions from the audience? We have one over there, please. And then.
Hi, I have a question for Hugo, please. So I was listening to the presentation, and I believe that the premise of you owning or being rewarded for the sustainability is that as a business you are more rational than the consumer in understanding that the initial cost can be amortized over a longer period, right? But still, as a business, why isn't this happening through a financial institution which would understand that rationale rather than the consumer who's not able to pay the initial high capex of owning such a technology?
It's certainly easier to have a conversation like that with fleet managers. They take a much longer view, but people always have an opportunity cost. And also, we argue that actually, in reality, we are very good in the industrial world at holding people to specifications. We're not very good at actually writing a specification of exactly what we want. And the only way to do that really effectively is for the company that is doing the work and holding the item on its balance sheet to make all those judgment calls itself. Because there are lots of, I mean, even down to micro decisions about quality control. If you're building an asset for your balance sheet, your attitude is entirely different to if you're building something to sell to a particular requirements document. And it would require everybody to take a very long view, no opportunity costs, no judgment calls, and so on and so forth. So you're absolutely right. It's about drawing an envelope around the life of the car and being able to make an entirely rational economic decision. But with multiple different entities, we don't think that that's actually plausible in the real sense. And this is why we're bringing in suppliers into the activity. If we buy components off our suppliers, they want the shortest possible life and the highest possible price. We want the lowest possible price and the longest possible life. It's not a great basis for a working relationship. And that tension will always exist once the costs are split up onto multiple sets of accounts. Even if we were to divide the company into 2 profit centers, we'd need a transfer price, and we don't believe that you could build the business like that and make it as effective and successful as keeping it all in a single profit center.
Thank you.
No more questions? Okay, one last question because we're out of time. Over there, yeah.
Hello. Yes, sure. This is Yara from Avera. I'd like to ask a question to Mr. Hugo. I totally understand why you chose fuel cells over batteries for your car, which is understandable because of the energy density and the efficiency, as you explained in your presentation. But I would like to ask, why did you choose ultra-supercapacitors as a storage system instead of batteries?
We don't use that storage system for any long-term storage. It is purely there to meet transients, when you have a transient spike of demand or transient energy inflow, so basically braking and going up and down hills. And the critical factor there is not actually the energy density, where batteries are better, but power density. The power density of capacitors is appalling, but it's getting better very quickly. But the energy density is appalling, but the power density is fantastic. So we can throw 1,000 amps at our capacitors. In fact, we're putting about 600 amps in at about 100 volts, so 60 kilowatts under braking, and it's only 40 kilos of capacitors. If we wanted to put 60 kilowatts into a battery, we'd need a battery the weight of the car. And if there are instances where we would use batteries in a triple hybrid, so if we were building a car for the Alps, for instance, we would need 10 to 15 kilos of lithium ion to provide the load leveling for all the potential energy of going up and down mountains. But capacitors are quite enough for a range of 500 meter altitude, 1,500 foot, and for all the acceleration and deceleration.
We're out of time, so we have to close up. Thank you so much. This has been very insightful.